So today we're getting ready to tune a Dodge Stealth twin turbo on the Chrome ECU. The Chrome ECU was originally a 99 and 98 flashable ECU from Mitsubishi that Greg Ellison modified to have a lot more features, and also he identified all the maps that we were able to edit. It allows us to do such great things such as change your injector size, latencies, change your fuel maps, time maps, redline, uh, injector, dead times, just all kinds of things that you can actually change now, and idle speed and things of that nature. So a lot of great things, a lot of things that you used to have a standalone ECU to do. If the Chrome ECU has any disadvantage, the biggest one is just that it does not have native support for speed density, and it does not allow for live tuning. As long as you are okay with that, then you can really get pretty far with Chrome. And the nice thing is the Chrome ECU is designed for your car. So basically, if your car's stock and your Chrome ECU is configured in the right way, then your car is just going to run just like stock. And so it's not going to take a lot of time. Even some advanced standalones like the Haltech take a little bit of time to get to run very good on your setup and perfect and things like that. Whereas the factory, had it pretty well figured out. And if you're just doing a mild setup, like putting, 5, 6, 700cc injectors in it, then they tune pretty dang quickly. So the first thing we want to do is we need to change the injector scaling for this car because it went from the factory ECUs to 550 DW injectors. And we need to change some things for that. But I'm not going to go change anything on this map until I identify how this has been tuned already. So we read from his ECU. We have his map, but I want to see how this is different from the original map. And so I'm going to go grab a known good copy of the original map, and we go to compare ROMs. And this is going to highlight any of the tables that have been changed in the map. And let's just go ahead and start at the bottom. MUT3 and OBD2 has to do with some of the data logging and things like that. I wouldn't get super concerned about that. This function here looks like on the modified tune for this car has been turned off, so that's fine. The peripherally has been changed as well, and it's going to highlight what's been changed. Biggest thing they did, which is a nice Chrome feature that Greg created, was it will show your check engine light will blink if you're experiencing detonation that the computer's picking up on the knock sensor. And so that's good to leave on, so that's fine. Some of these other features we don't really need to worry about right now, but Chrome does support launch control and no lift to shift and some custom outputs as well. You can even get your active exhaust to work again if you're using Chrome here. Another feature is you can turn your fuel pump on with the key instead of just on cranking, which I usually don't do, but if for some reason your fuel system leaks down really badly, it can make it start a little bit quicker. But I do think it's a nice safety feature that these cars don't run the fuel pumps unless you're cranking or the engine's running. So nothing really too big here so far. Let's keep scrolling up. So turbo load error correction. It looks like this map has been zeroed out. So if we look at load error correction on the factory map, you can see that it can, if it detects you're getting more engine load, which is how this ECU interprets airflow, which is related to boost, it will reduce the wastegate duty cycle up to this -9 here if your boost is overboosting, and it will add boost if it's underboosting. This has been zeroed out in this car, which I normally would say that you shouldn't do, but this car actually runs a manual boost controller, so that's probably why this has been done, and it's certainly not going to harm anything since this car is running a manual boost controller. Ideally, you would run the factory boost control and use a boost solenoid, and you can actually run a max solenoid with these ECUs with the right configuration. Because the stock one is just not very good once you start running high boost. The stock boost controller doesn't hold up very good. But for simplicity's sake, it looks like they've switched to a manual boost controller, which is totally fine. It's just you lose some safety features and the ability to run less boost when it's cold or when it's hot, or certain RPM ranges, things like that. So this is not a problem either. So again, we're just reviewing this current tune because if this current tune is nice, I would rather start with this and scale the injectors and change the uh, coil dwell with rather than starting completely over, because this car was running great when it came in here and I don't want to lose out on any of the tuning that they've already done. So let's go ahead and keep going. Looks like none of this has been altered. The ignition maps have been changed. So you can see here, this ignition map has had significant amount of timing removed. So let's go ahead and look at the stock map. So as you see the stock map on heavy load, which this is running the wide maps right now. So Greg modified these to have resolution over 160 load, which is really nice. And then it just runs the same for higher loads, but if you go into tuning higher boost, you can run less timing at higher boost and things like that. But it looks like this car has been had a lot of timing taken out of it. I thought when I first saw this that maybe this was because the car has if it has the first early cam sensor, which has the crank and cam sensor in it and runs on the passenger rear head, then there is actually a difference in the pickup latency, the pickup comp delay, because the earlier ones are optically driven, the pickup, and the later ones, it's a Hall effect magnetic sensor. So long story short, but due to that, if you're running a later ECU on the early type of sensor, you will have approximately 4 degrees too much timing up top. The formula is actually to take the RPM times 0.0005, and that is how much timing you should take away from the cell that you're in. But this car doesn't. So this car has the independent cam and crank sensors on the driver's side, and so I'm not sure why they pulled so much timing out of this. I'm also not sure why they left this so rough. So as you can see in the stock map, at a certain RPM here, right around 4,000, it goes from 10 degrees of timing to 12 to 19. And I believe they did this because these cars are very prone to knocking at the 4 to 4.5 range. It's probably due to where peak torque comes in on the stock turbos, and or the physical mechanics of the engine are just noisier at that range. Um, but this makes the car, you can really feel when it does this. When I test drove this particular car, you can really feel when it does this 7 to 14. It really is not super happy. And so I don't like this timing map. So let me show you one of the final timing maps I was running when I had Chrome on my car. So if we look at this, look at our high octane map here. Okay, sorry, this is actually just a copy of the stock map. I got the wrong one here. Let's look around here for a second. I haven't had Chrome on my particular car for about 10 years, and so it's kind of difficult to know what's going to be the correct map here. But one of these actually has a nice timing map here. Let's see. Yeah, so this is a pretty nice map. It's pretty conservative still. You can see here at loads we're likely to encounter on this stock turbo setup. It's running about 17 or 18, which is pretty similar to what the car currently is set up for, but I don't have this gigantic jump anywhere that the car currently is set up for that the stock map had. So basically this is a smooth stock map with 4 degrees less timing, and this is just a safe place to start. If the car is happy, we could start feeding that timing back in. But I know this map is completely safe and the client's not going to experience any detonation like this. So we're going to go ahead and copy this map to his. So we'll go back to this one right there, because I basically don't like this super roughness here. And so you can see how much that smoothed that out. I think we'll go ahead and do the same thing with the low octane map, which is simply a smooth map with even less timing. The cars will start to interpolate between the low and the high octane maps when they pick up on detonation for a little bit of time. So the car basically has an octane value stored in it that's like a fuel trim, but it's for octane. And as it detects more and more detonation, you will have the octane value go down, and so it will uh, go to lower timing. And so it's basically the ECU strategy is to lower the timing, lower the boost when it has boost control, and also richen the car when it's experiencing detonation. You have to remember these cars were designed that if someone were to put 87 octane in them and still go drive it like normally at full throttle and things, that they would not immediately explode. And so that's what this is designed to help handle. And so that's a good thing. And it's a good thing to keep your low octane map tuned. It's just not an area that we're going to spend much time on. We're just going to take basically the high octane map, maybe remove 4 or 5 degrees of timing, and that way the ECU still has some control if things get out of hand here. So let's keep going. So that's the timing maps. I'm going to go ahead and close my map because it gets confusing pretty quickly on these. Go back to this. I saved this file as a different file name, and we will increment these as we go, like 1, 2, 3, 4, 5. That way we always can go backwards, and we always know what the car had originally in it. Looks like there's another map that's been changed here for minimum coolant for idle correction. On the stock map, that is basically 100 degrees, but it looks like this has been set to a very high value, so essentially the car is not trying to do any idle correction. I'm not sure why you would want to do that, unless it's a band-aid for some mechanical problem. It's nothing that I've ever had to do on a car, but we're going to go ahead and leave that the way it is, because an important thing about tuning is to keep an eye on changing as little as possible per iteration of what you're trying to do. And so if you keep changing a whole bunch of variables, many, many at a time, then you're going to be chasing your tail and have a lot of trouble. So we don't want to change anything that we don't really feel we need to yet. Okay, same thing with the high and low fuel maps have been changed. So it looks like they've been leaned out a little bit because the stock map is quite rich. See here, if we look at the stock map, we're down to the 10.2s, which is about what they run. And if we look at this modified map, it's an 11. Now, one thing to keep in mind is that is not a genuine, true AFR. This is more like a power enrichment table in HP tuners or something like that. But if the car is tuned really well, these can become representative numbers. And so if you data log a wideband and you work on the car, this can actually mean that the car really is running 11 there. And so there's several different factors that impact your overall AFR. There's probably dozens actually if you really get into it. But the big things are the fuel injector tuning and the MAF scaling in the ECU. The way I like to tune these cars is I like to get the injectors dialed in first. And so essentially we're going to go down to the fuel injector scaling. And so down here we have, under fuel, we have injector scaling. So I'm looking at the stock map, which is set to 361 because the factory injectors are 360s. We look at this modified map. It's also set to 361 because this car came in with stock injectors. So we're putting 550s in the car, but I don't want to go straight to that. Let's be a little conservative and go to 526 here. This will give us, 5% extra fuel over what should be calculated. And that way we can sort of safely approach this without going too lean. And this is not a volumetric efficiency ECU like a Haltech or a Link or something where the injector sizes are fixed in stone like that and actually do exactly what they're supposed to. So you can't like if we put 880s in this car later and we switch that, it'd be unlikely that it would run perfectly by switching those to 880s. It would probably need more tuning. But it's a good place to start. With that, you also have your injector battery voltage compensation. This is basically what the stock type of map calls for injector dead times. 550s right here. So if we look at that, this is going to pull up some spreadsheets with some data. I'm going to go ahead and go to AEM data because obviously they don't have any data for Chrome. And here's what we have right here. So basically, you're going to take the closest voltage that you can in Chrome and put this value in there. So we're going to grab the 0.67 for 14 volts and so on and so forth. So, and they may not have data for all the ranges, so because they don't expect the car to ever run at 18. So we'll just take our best guess for that. For 16 volts, they show 0.53. So I'm just going to put a little bit less in case the car ever does get to 18 volts. For 12 volts, they have 0.87. For 10 volts, they have 1.12. For 8 volts, they have 1.44, which again, your car should never get that low. And for 4 volts, which DW only supplies for 6, they have 1.8. So I'm going to go ahead and make this value a little more than that. Again, the car should never reach this. If it does, something's probably wrong. We do want to have values in there that make as much sense as we can. So what we've done so far is we've set the injector scaling. We've set the injector compensation, which is basically the dead times. And when we tune the car, we're going to start this car and we're going to let it idle. And approximately every 4 minutes, it will update its trims. So you have to let the car idle for 12 to 16 minutes to really get the trims to go far enough to where they're supposed to be. And if we find the idle is rich, we would subtract some latency from your injector latencies. If we find the idle is lean, we would add some. And so basically the ECU is taking what it thinks the injector open time should be and it's adding the injector latency to that. So you can imagine that at idle, this has a much greater effect than it does at high power because your injectors might be open for 2 or 3 milliseconds at idle, but they might be open for 18 milliseconds at full throttle. So long story short, your latency is going to have a lot bigger effect at idle, but your scaling is going to have a bigger effect at full power and the mid trims. So basically, I'm going to try to dial in the trims by looking at the idle and mid trims and adjusting our latencies until the idle's happy and adjusting our injector size until the mids are happy. From there, you start doing some power pulls at low RPM. So we're basically starting like second gear, do from 2,500 to 4,000, make sure it's happy. And if it's ever not happy while you're trying to do that, don't keep your throttle into it. We'll also be starting this out at low boost. So this car has a manual boost controller. We'll turn it all the way to low. We'll try this out at like 6 pounds of boost, so it's extra safe. And we will get the logged AFRs to basically match what's in our high octane big fuel map. And you can do that by adjusting the injector size, or another option is to look at the MAF scaling tables. So if we look at our math smoothing table here, you can see this is based off airflow. So that gives you a lot of control over the fuel ratios at higher loads. So at full throttle, you're probably going to see over 1,600. And so if your car was running lean, you add numbers to this, 107. And if it was running rich, you could subtract. The important thing is to do a good log, go through these different airflow areas, and then try to adjust this until your commanded fuel ratio in your high octane big fuel map matches what it's actually doing. And with this table properly tuned and your injector sizing and latency is correct, then this table will become accurate. And that way, if you decide, well, I want to even go leaner than this, I want to run 11 and a half, pick up a little more power, use a little bit less fuel, you could just change this to 11 and a half and validate that that actually happened, and you'll be good to go. If you start adjusting your high octane fuel map table to fix your AFR, then these numbers will never match. So if we go drive the car and it's running 12 to 1, and we know that's too lean for pump gas on these old turbo cars, and we change this to 10 to try to fix that, yes, it may have the effect of fixing it, but it's really going to be confusing when you look at this car later or you try to make adjustments. So we're going to balance out our MAF smoothing table and our injector size and our injector latencies to get the car dialed in. And so this process takes a little bit of time, and it's something you want to approach cautiously, slowly, make sure everything's happy. But once you get your trims plus or minus 5%, usually the full throttle tuning is pretty easy. Um, so the last thing we need to change, because this car has a VENGE Coil-on-Plug kit, is we need to go down to our ignition again. So we'll go to coil dwell time versus voltage. There are some other tables here that do matter. So you can check out here, the stock ECU does reduce dwell after 2800 RPM. It does have a time limit here. If you find the car tends to misfire, even with a quality ignition setup, this can be changed to like 90%. Unfortunately, this works a little differently than most setups where it's just a flat table that has dwell time versus RPM. But you can still work with this once you kind of understand how it's working. So a lot of times we'll turn this to 90%, and that'll usually do it. So that'll usually do the trick, along with setting the dwell correctly. So the factory dwell is actually more than is needed for the Coil-on-Plug kit. So if you try to run the factory dwell times with our Coil-on-Plug kit, you will overheat these coils. It's happened. I've had some cars that after you drove them for 45 minutes, it would develop a misfire. So for our Coil-on-Plug kit, we have some pretty good instructions here. If you look at our detailed instructions in FAQ, and it explains in here what you need to put in here for the dwell times for various ECUs. So we have some dwell settings for AEM, and we have some dwell settings for Haltech, and we have some dwell settings for Chrome. So, and this is what you want. So we're going to go ahead and look at our Chrome dwell settings. Right there. And we're going to go ahead and grab our ECU flash settings here. Try to make this see them both at the same time. So here's our coil dwell. So you can see here, these top three fields here need to be set to 1.47. And then this one needs to be set to 1.792. And then this needs to be set to 2.5. This needs to be set to 3. This needs to be set to 3.3. This needs to be set to 5.7. And again, mostly the areas where you're actually going to operate the car is what needs changed. So pay extra attention to them. It actually looks like I made a mistake on the 14 line here, so watch that. Let's validate everything's correct. 1.472. At 15, we're supposed to be running 1.8. And then at 14, we're supposed to be running 1.9. And then 2.5, 3, 3.3, etc. So that looks correct. So that's really all you should change for the Coil-on-Plug kit. Not a big deal. Look at our graph here, and we can see if there's any huge problems in this graph, and there's not. So I just wanted to make sure I didn't miss any settings. So next we're going to push this tune to the car. And to do that, you're going to need an open port 2 cable from Deatschwerks. And you're going to want to make sure that you've had the car on a battery tender or battery charger for a while, because if the voltage dips too low, it can and will brick the ECU. And so in these ECUs, it's hard to get repaired if they ruin the microprocessor in them. And so it's just something you really want to avoid. So if you're doing small changes to the tune, it actually only updates the data ranges that it needs to. And so it's not as dangerous, doesn't take as long. You still should put a battery tender on there if you can, but I understand if you're driving around and you can't. But if you're updating to like Chrome 2 from Chrome 1, you 100% should, because it takes a very long time. There's a lot of writing going on, and your battery voltage can dip in that time frame. The problem kind of arises from the voltage required to flash these ECUs. It's something like 19 or 20 volts, and so the little Deatschwerks device has some type of voltage. I'm not going to say transformer because you can't really transform DC, but there is a voltage regulator in it that's capable of increasing the voltage. And so if your battery voltage is too low, it's just going to really struggle to keep that voltage up, and it can break the ECU. So plug it in. So we'll get back to you once we get the car started and just let you know kind of how it's going.
Okay.
Well, we burned the tune to the car, and we're going to go ahead and fire it up. I don't think it gets much better than that. So like I said before, we're going to let it idle up to temperature, and we're going to check the trims and adjust from there. So the client opted for a stealth installation of his wideband, and we can see we're running a touch lean here, so we're going to let the car idle up to temperature and see if that trims down. It should. And then we'll see what the trims are. Okay, it warmed up some more, and it is definitely adding some fuel now. We're at the maximum trim for the low trim, so we're going to add a little bit of latency to the injector setup, and that should help with that. So we added 25% to the injector dead times, and we are seeing about 9% of added fuel instead of 12, which 12 is the limit. And we can also see that our fuel ratio is much closer to what it should be. So that was definitely a step in the right direction. We've added a significant amount to the dead time, so I'm actually going to reduce the injector scaling to 500 instead of 525, and that's going to richen it across the board, because when I rev this a little bit, it's actually pretty good now, but before it felt just a little bit hesitant. And we'll have to see what code is tripping right now. It's tripping something. Probably a periphery needs shut off in Chrome, but this actually isn't too far off. We're trying to get that to 0 initially, but anywhere from -5 to +5 is totally fine. So it's actually getting pretty close.
I like the noise the turbo makes.
So we changed the injector scaling to 500. We can see that the low trims are about 5%. So at this point, I probably wouldn't change anything until the car has had some time to idle. And then we're going to drive it, and then that will allow the mids to start coming in too. And then we'll have a better idea of what it really wants. But this is actually close enough right now. We will get that closer to 0, but it's smarter to just let the car idle and figure out what it really wants first before you start making more and more changes. So, and Eli had a question. So the reason these trims, if these trims are positive, the reason you want to add fuel is because a positive trim means the computer is commanding more fuel than its built-in maps thinks it should, basically. And so we add fuel to get that trim to get closer to 0. If this is a negative value, the car's actually running rich, even though the computer appears to be pulling fuel. That's because it is trying to pull fuel.
VENGE Performance is the place to get the parts and the advice to help right the wrongs on your vehicle. We partner with the industry leaders in parts distribution and warehousing to get you the best possible prices, the widest selection of parts, and the fastest shipping. With our real-time inventory on our website, if we say we have it in stock, it's ready to ship. From us or from our many national distribution partners. With hundreds of thousands of parts available, I guarantee we can get revenge on your ride.